TSMC produces 90% of the most advanced processor chips. From Apple, whether it's an iPhone, or NVIDIA, which powers many data centers, TSMC produces many of their chips.
Imagine a world where cars can't start, smartphones remain unfinished, and factories grind to a halt, all because of a component no bigger than a fingernail. These components are semiconductor chips, the tiny brains that power virtually every electronic device in the modern world. From the processor in your laptop to the sensors in a car's engine, semiconductors are the invisible force driving our digital age. At their core, these chips, be they microcontrollers, memory units, or integrated circuits, enable machines to compute, communicate, and perform complex tasks with astonishing speed and precision. As technology continues to expand into every corner of human activity, our dependence on these microchips has grown exponentially. Today, we'll see how this $1 chip could collapse global power. Let's get started. The global chip shortage. Before 2020, the global semiconductor industry operated through a vast and intricately balanced supply chain. Major chip design was concentrated in the United States through companies like Intel, Qualcomm, and NVIDIA, while manufacturing was largely outsourced to a handful of foundries, especially in East Asia. Taiwan Semiconductor Manufacturing Company, or TSMC, based in Hsinchu, Taiwan, handled more than 50% of global chip fabrication, followed by Samsung in South Korea. Other crucial nodes in the supply chain included ASML in the Netherlands, which supplies lithography machines, and countries like Japan and China, which produced raw materials and specialty chemicals. Despite the complexity, this system was relatively stable and efficient, optimized for just-in-time delivery with minimal excess inventory. And then COVID-19 shattered this balance. Automakers around the globe, including General Motors, Ford, Toyota, and Volkswagen, anticipated a steep decline in car sales due to economic uncertainty and lockdowns, prompting them to slash orders for chips and components. Simultaneously, demand for consumer electronics surged as millions of people transitioned to remote work, online education, and digital entertainment. Chip manufacturers, including TSMC and Samsung, quickly reallocated their production capacity to meet the booming demand for laptops, tablets, webcams, and gaming consoles like the PlayStation 5 and Xbox Series X. This shift created a cascading bottleneck. The capacity vacated by automakers was quickly filled, leaving no room for a sudden rebound in automotive demand. By late 2020, the situation began to spiral. The automotive industry experienced a faster-than-expected recovery, but when car makers attempted to reorder semiconductors, they found that production slots had already been taken. Semiconductor fabrication plants, or fabs, require months to adjust manufacturing lines, and many chips used in cars, such as microcontrollers and power management integrated circuits, are built on mature nodes, like 28 nanometers, which have lower profit margins and were being phased out by some foundries in favor of cutting-edge 7 or 5 nanometer technologies. As a result, the industry could not pivot quickly enough to meet the spike in demand. Meanwhile, manufacturing hubs in Malaysia, Taiwan, and parts of China were hit by new COVID-related disruptions, including strict lockdowns and labor shortages, which further delayed chip output. Global port congestion, especially in China's Yantian and Ningbo ports, also restricted the movement of raw materials and finished chips. The chip shortage intensified in 2021 and into 2022, exacerbated by a series of unforeseen disasters. In March 2021, a fire broke out at a key Renesas electronics chip plant in Naka, Japan, which produced nearly 30% of the automotive microcontroller chips used globally. At the same time, a historic winter storm in Texas forced the shutdown of multiple semiconductor facilities, including those operated by Samsung, NXP, and Infineon. These shutdowns dealt a severe blow to the already strained supply chain. On top of this, geopolitical tensions between the United States and China contributed to panic buying and stockpiling of chips by Chinese firms. This further tightened global availability. Washington's export restrictions on Chinese tech companies like Huawei also disrupted the balance of chip allocations, as firms scrambled to secure alternative suppliers or hoarded stock in anticipation of further sanctions. The fragility of the global semiconductor supply chain became undeniable. The automotive sector, which relies on roughly 1,000 chips per vehicle in high-end models, was among the hardest hit. The chip shortage cost the auto industry over $210 billion in lost revenues and resulted in the production of 11.3 million fewer vehicles in 2021 alone. Companies such as Ford and GM were forced to idle factories, delay new model launches, and ship vehicles without certain features. In one notable case, Ford shipped some pickup trucks without rear climate controls, promising to retrofit them later when chips became available. Meanwhile, consumer electronics companies faced their own hurdles. Apple cited chip shortages as the reason for trimming iPhone 13 production targets by 10 million units in late 2021. Efforts to mitigate the crisis were slow to bear fruit. Building new fabs requires billions of dollars in capital and at least 2 to 3 years of lead time. Nonetheless, several governments responded with strategic investments and industrial policies. The United States passed the CHIPS and Science Act in 2022, committing $52 billion to boost domestic semiconductor manufacturing. The European Union launched its own CHIPS Act with the goal of doubling Europe's global semiconductor market share to 20% by 2030. Countries like India and Japan also began offering subsidies and forging partnerships with companies like TSMC and Intel to attract chip foundries and reduce import dependency. The pandemic did not create the fragility. It exposed and accelerated it. Even small disruptions, such as the unavailability of a $1 microcontroller, had ripple effects that brought multi-billion-dollar industries to a standstill. As nations and corporations rush to localize and diversify chip production, the world may emerge more resilient, but only after navigating the lessons of one of the most consequential supply chain crises in modern history. The $1 chip crisis, a symbol of bottleneck economics. Microcontrollers, voltage regulators, and power management integrated circuits are small yet indispensable parts responsible for regulating power, interpreting sensor data, or executing basic computing tasks within a larger system. These chips cost as little as $1 to $5, and though they lack the complexity and processing power of high-end processors, they are foundational to the operation of modern automobiles, home appliances, smartphones, medical devices, and industrial systems. In the automotive sector, these low-cost chips are used in virtually every subsystem. They regulate anti-lock braking systems, deploy airbags, control electric window motors, manage infotainment units, and help coordinate engine timing and fuel injection. Even a single missing microcontroller can halt the final assembly of a vehicle. Each modern car contains between 300 to over 1,000 chips, and their seamless operation requires all components to be available and synchronized. When the pandemic disrupted global chip production, it wasn't the high-end semiconductors that caused immediate chaos, but these basic, often overlooked components, the $1 chips, that brought manufacturing lines to a standstill. The scale of the crisis became visible in 2021, when General Motors was forced to halt production across several major North American plants, including facilities in Missouri, Michigan, and Ontario. The company reported a production shortfall of 1.1 million vehicles that year and estimated a loss of $2 billion in operating profit due to chip-related delays. Similarly, Ford Motor Company announced that it would slash the output of its flagship F-150 pickup truck, one of the best-selling and most profitable vehicles in the US market. In some instances, Ford shipped vehicles with missing features, such as advanced driver assist systems or rear seat climate controls, promising to install the missing chips later. In May 2021 alone, Ford reported a $2.5 billion drop in profits, attributed largely to semiconductor shortages. Toyota, long hailed for its just-in-time inventory strategy and historical resilience against supply shocks, also found itself caught off guard. Although it initially fared better than rivals due to its practice of stockpiling semiconductors after the 2011 Fukushima disaster, Toyota eventually had to cut global production by 40% in August 2021. The company reduced output at 14 Japanese plants and several overseas factories, citing the unavailability of key chips needed for hybrid systems and electronic control units. Despite decades of finely tuned logistics and supplier relationships, the automaker acknowledged that no company could fully shield itself from a supply crisis of this magnitude. The reason these $1 chips became such critical choke points lies in the nature of semiconductor manufacturing itself. Most of these essential components are built on older manufacturing nodes, such as 40 or 90 nanometer processes, which are no longer cutting edge but are perfectly suited to their specific functions. Foundries like Taiwan Semiconductor Manufacturing Company, or TSMC, and Global Foundries had been shifting resources toward advanced 7 and 5 nanometer technologies to serve higher margin clients like Apple, AMD, and Nvidia. As a result, the capacity to produce older, lower profit chips was constrained even before the pandemic. When demand surged across all sectors, there simply wasn't enough capacity left for the low end. The situation was further complicated by the geographic concentration of chip fabrication. TSMC, based in Taiwan, controlled over 50% of the global contract chip manufacturing market in 2021. A drought in Taiwan and COVID-19 restrictions slowed production at key fabs. Renesas Electronics in Japan, which supplied nearly a third of automotive microcontrollers globally, suffered a devastating fire at its Naka factory in March 2021, removing a vital source of supply. Meanwhile, Malaysia, a hub for chip packaging and testing, saw factory closures due to strict lockdowns, choking another link in the supply chain. The crisis revealed a profound vulnerability in global supply networks. In an era of just-in-time manufacturing and global interdependence, even the smallest and cheapest component, as we saw, can become the single point of failure. As countries now push for semiconductor independence and companies rethink sourcing strategies, the lesson endures. One country, however, feels confident that it can help prevent such a disaster again. That country is India. India's position and the 2016 to 2026 Automotive Mission Plan. India's 2016 to 2026 Automotive Mission Plan, or AMP, was ambitiously crafted to propel the country's automotive industry into a global powerhouse. Launched in September 2015 by the Society of Indian Automotive Manufacturers and the Government of India, the plan set a goal to increase the sector's contribution to 12% of GDP by 2026, aiming for an industry valuation of $260 to $300 billion and the creation of 65 million jobs. The vision was clear: make India one of the top 3 automotive manufacturing nations through the Make in India initiative, promote electric vehicle adoption, and boost exports to account for 35 to 40% of production. Despite early momentum, the global semiconductor shortage that emerged from 2020 to 2021 posed a formidable threat to these lofty goals. Before the pandemic, India's automotive sector was steadily progressing, contributing about 7% to GDP, generating 19 million jobs, and supporting 45% of the country's manufacturing output. By 2022, it was the world's 4th largest auto producer, valued at over $100 billion and contributing 7.1% of GDP. However, the semiconductor shortage disrupted this growth trajectory precisely as the AMP aimed for expansion. EV production, a focal point of AMP's future strategy, suffered significant delays as chip-dependent systems like battery management units, infotainment, and driver assistance modules could not be assembled. India's reliance on imported chips exacerbated the problem. Virtually all automotive-grade semiconductors used by Indian original equipment manufacturers like Maruti Suzuki, Tata Motors, Mahindra, and Hyundai were imported from Asia-Pacific foundries, most notably Taiwan's TSMC, South Korea's Samsung, and Japanese firms like Renesas and Toshiba. Domestic capacity for chip design, production, or assembly was practically non-existent by 2021, leaving manufacturers vulnerable to global supply disruptions. Recognizing the urgency, the Indian government rolled out a multi-pronged policy response between 2021 and 2023. Key among these measures was the Production-Linked Incentive Scheme, announced in 2021 with an initial outlay of $10 billion to develop semiconductor and display manufacturing ecosystems. In June 2023, Micron Technology of USA committed to invest $2.75 billion under this scheme to set up assembly, testing, marking, and packaging facilities at Sanand, Gujarat. Simultaneously, Tata Electronics entered an $11 billion partnership with Taiwan's Powerchip Semiconductor Manufacturing Corporation to build India's first 28-nanometer fabrication facility in Dholera, Gujarat. The project also includes a $3.3 billion chip packaging and testing plant in Moregaon, Assam. Beyond Micron and Tata, India has cleared several semiconductor proposals under its December 2021 scheme. These include OSAT assembly, testing and packaging plants by Kaynes Technology in Gujarat, with a capacity of 6.3 million chips per day, and CG Power, in collaboration with Japan's Renesas and Thailand's Stars Microelectronics. Foxconn too expressed interest in multiple fabs and is exploring joint ventures with TSMC and Japan's TMH Group. Infrastructure initiatives like PM Gati Shakti, launched in August and October 2021 as a $1.2 trillion multimodal connectivity plan, also seek to streamline logistics critical for chip manufacturing. Meanwhile, academic industry partnerships are strengthening semiconductor R&D and talent pipelines. The government's Design-Linked Incentive Scheme, in collaboration with EDA firms like Cadence and Synopsys, is building training centers. While Indian startups such as Sahasra Semiconductors and L&T Semiconductor are also emerging. These initiatives mark a profound shift in India's economic strategy. Where the AMP once emphasized vehicle manufacturing and job creation, by 2021, the crisis had highlighted the necessity of foundational semiconductor capability. The PLI scheme alone seeks to support wafer fabrication, packaging plants, and fabless design. These achievements no longer exist in isolation, but are essential cogs in the automobile industry envisioned by AMP 2026. Despite these efforts, challenges remain. Semiconductor fabs can require 2 to 3 years to become operational, meaning India's capacity gains will materialize around 2026. So far, 45 proposals have been submitted under the semiconductor scheme, stoked by hopes of turning India into a global hub by 2030. Yet execution and scale-up remain a hurdle. But India is not alone in recognizing the challenge. Steps taken to address the crisis by major powers. In August 2022, the United States passed the landmark CHIPS and Science Act, committing approximately $52.7 billion to revitalize domestic semiconductor manufacturing, research, and workforce development. This includes $39 billion in manufacturing incentives, a 25% investment tax credit for equipment, and $13 billion targeted at R&D and training to rebuild American capacity previously lost to overseas fabs. Under this act, key industry players such as TSMC, Samsung, Intel, and Micron are receiving grants and support. TSMC's Fab 21 in Phoenix, for instance, was offered up to $6.6 billion in direct funding under CHIPS for its third fabrication plant, pushing total investment there above $65 billion. By early 2025, construction work had begun on multiple advanced fabs using 4, 3, and eventually 2 nanometer process nodes, projected to create at least 6,000 high-tech jobs plus tens of thousands of ancillary roles. Simultaneously, the European Union's CHIPS Act, enacted in July 2023, seeks to double the EU's share of global semiconductor production to at least 20% by 2030. The initiative features a 3-pillar strategy: funding large-scale manufacturing with 43 billion euros, of which 3.3 billion euros is the EU budget, supply chain monitoring and crisis readiness, and frameworks to support startups and SMEs through state aid exemptions. The EU holds around a 12.7% global market share, with ambitions to climb to 20%, though a European Court of Auditors warned this target might be aspirational without accelerated investments. Several other countries are launching similar strategies. Japan offered nearly $8 billion in subsidies to attract chipmakers like TSMC to build fabs domestically, including a planned 28nm facility in Kumamoto Prefecture, under negotiation. India, likewise, has earmarked around $10 billion to bolster semiconductor and display manufacturing, facilitating partnerships like Micron's $2.75 billion assembly, testing, and packaging facility in Sanand, Gujarat. Recognizing that government actions alone weren't enough, private sector leaders are also scaling up. TSMC's heavy investment in Arizona, expanding Fab 21 into a 3-fab campus with the latest node capacity, is the single largest foreign direct investment in US history, now totaling over $165 billion. Intel, supported by nearly $20 billion in CHIPS Act funding, is building new plants in Arizona, Ohio, New Mexico, and Oregon to restore its advanced chip-making footprint. Samsung is constructing a $17 billion fab in Texas, and GlobalFoundries is actively building a new facility in upstate New York, all underpinned by US incentives. Additionally, original equipment manufacturers like Ford, GM, and Volkswagen have struck long-term procurement agreements with chip suppliers and are redesigning systems to use fewer chip types or more standardized ones to reduce bottlenecks. By late 2023, these collective efforts began to ease supply tensions. According to IC Insights and industry tracking, chip inventories stabilized and fabrication backlogs declined. While some markets, such as graphics cards and MCUs, continued to normalize through 2024, input for automotive and consumer electronics rebounded to near pre-pandemic levels by early 2025. Today's supply environment reflects a new normal. Manufacturing stakeholders are shifting from lean, just-in-time inventory models to strategic stockpiling of critical components, diversification of supplier bases, and active investment in redundant production lines. Companies now routinely include buffer stock estimates and stress test their procurement against disruption scenarios. The crisis fundamentally reshaped how we view even the smallest components. The $1 chip showed how a missing part, even if minuscule and inexpensive, could delay a $50,000 vehicle. That lesson forced nations and industries to reckon with bottleneck economics and prioritize redundancy alongside efficiency. Looking ahead, semiconductor self-reliance is a declared national imperative across Asia, North America, and Europe, not just for economic resilience, but also for national security and technological sovereignty. Strategic investments from CHIPS, the EU CHIPS Act, Japan, India, and others have stimulated hundreds of billions in new fab projects, research centers, and workforce training programs worldwide. While large-scale fab construction still takes 2 to 4 years to yield output, the wave of new facilities marks a transformative turn in global chipmaking. If successfully executed, this semiconductor renaissance could build the most robust, geographically distributed, and future-proof chip ecosystem ever. Well, that's it for now. Thanks for watching. Did you like this video? If you did, please consider liking, dropping a comment, and hitting the subscribe button so that you don't miss out on our new uploads. Also, don't miss this video you see on your screen right now. It's truly unbelievable.